for joining with us today for another session of Industry Mentoring Program. This evening, we are very lucky to have, I'm always very lucky to have one of my students. So thank you so much, Ms. Dimuthu Leelaratna. We are very fortunate to have Dimuthu joining us for this session. A very senior IT professional, but who is always young at heart, who always probably remembers her days at the university. So I'm not going to introduce you, Dimuthu. You can tell them about your journey on behalf of CODL and the students of BIT degree program. I'm very grateful to you for joining with us. So children, as I keep on saying, it's not every day that you get a chance to meet a senior IT professional like Ms. Dimuthu. So any questions you have, make sure that you ask them either through the chat while we are going on or once when she finishes. You can always ask questions. So thank you everybody for joining. Over to you, Dimuthu.
Thank you, madam. So I'm Dimuthu. Right now I work as a senior architect at Wiley. I have over 17 years of experience in the industry, in the IT industry, as at various roles. Out of those 16 years, I spent like nearly 12 years as a developer. So today I'm going to highlight little bit of that. I'm going to share a little bit of that experience with you. So I have worked at MIT. I have worked at WSO2 for nearly 12 years. So it has been an enjoyable journey, certainly not easy, but really satisfying. So let me share a little bit of my experience with you. So at any time, feel free to stop and ask questions. I will try my best to answer them. So let's get started. I hope you can see my overview slide now. So I will start off with an introduction to software development. Then I will walk you through a typical day in our lives. After that, by looking at the typical day, I will highlight the skill set required. And finally, I will end up with a small section on managing the support days. So what is software development? So if you say software development, it's not just writing code. It's a process of identifying requirements, doing the design, writing code, doing QA, writing the documentation both for developers and users, and then finally deploying it and maintaining the application. The whole process is software development. So addition, I mean, we do have specialized folks at these different phases. Like, for example, we have business analysts identifying and documenting requirements. And then we have software developers writing code and QA folks doing the testing. We have tech writers writing documentation. And then we have SRE engineers or system administrators in the new term SRE or DevOps folks doing the deployment. So those are very specialized roles. And I think different people will talk to you about from these different perspectives. Today, I'm going to talk to you about being a software developer, a person who specializes in writing code part. And I want to highlight, I hope by the end of this session, you will take away one important aspect, and it's just not writing code. So because it's a lot more other things that you have to do when you become a software engineer. Right? So let's get started about a typical day. So we usually start the day with This is Scrum at Rugby. We use the same term. This is Scrum at our office. Like this is not exactly our office, but something like this. This is where we gather every day. We stand up from our chairs, we gather and talk about three things: what I did yesterday, what I'm planning to do today, and whether I am blocked. So we are only supposed to talk about three things. One person speaks at least maximum 2-3 minutes, and we're supposed to finish it off. So here we don't talk about problem. We don't talk about solutions to our problems, why we are blocked. Here we only it's like a huddle. So if you ask me in this COVID situation, how do we manage to have daily Scrum? We have it via Teams. We have it remotely. That's daily stand up or daily Scrum was not so important when I went to office, because anyway I meet people, anyway I have lunch with them, anyway I talk to them in the lift, anyway during lunch we talk about work, during lift in the lift we talk about work. I don't know. I mean, we had a lot of noise coming from the environment that fed us what happening, what each one of us did. But after COVID, this made real sense, and without this, I don't think our companies could function. Even restaurants. This is not only for software industry. I see that happening in many industries like restaurants, supermarket chains. So this is how we start the day. So as I said, what are the advantages? This Scrum meeting has these advantages. It keeps up, it bring all of us onto a same ground, and we can identify correction points. Basically, we are not supposed to talk about correction points at that time. We are supposed to say, okay, we have to correct you. Hold on, you have to wait. Let's finish the Scrum and take it up later. If someone says a problem, we say, okay, that's great. Let's talk about it after the Scrum. So we have a quick 15-minute stand up, and that's how we start the day. Basically, it for me, I have seen massive benefits. It allows self-organizing, self-discipline. The team can see what you are doing and what you are not doing also. So if you keep giving the same update every day, I wrote the inventory booking algorithm today. Tomorrow also, if you go and say the same thing, day after tomorrow also you go and say the same thing, people identify that you are actually not contributing much. It's like when you tell someone I'll do it, and you have to do it because you are a responsible person and you have to do it. So the Scrum meeting has all of these advantages, and that's how we usually start the day. That doesn't mean we have the Scrum at 8 a.m. Some teams have at 10, some teams have at 2, but it's like the break point. So if I said yesterday at 2 p.m., I'm going to finish this task, I have 24 hours to finish it. So I kind of think of it as the start of my work day, because that's where I say I did this, and within next 24 hours, I'm going to do this. That's where I commit to something. So that's how we usually start our day. This brings me to something called a software development process. I really need to talk about the software development process before talking about the day, because current software development process, modern software development processes are different to traditional ones. What is a process? So process is set of activities you do to achieve a goal, to achieve a target. So software development process is a set of activities that you do to achieve the final product required by the customer. So initially, we had this very rigid structure where you first write the requirements document and then finish it, then do the design. Only after you finish the design, you do the implementation. Only after you write the code, the QA person test it, and we have different dates. Okay, on 21st of March, you finish the requirements document. Like that, we had very rigid dates. But if you take modern software development processes, things are merged because we do continuous planning, we do continuous development, continuous QA. The QA person and the developer are tightly work very closely. Like previously, you can say feature finished. Then the QA person said feature not finished. That's a bug. So that cannot happen in this kind of scenario. The feature is developed and tested and delivered by the team, not one person developing, the other person is saying not ready. So we do continuous planning, continuous requirement gathering, continuous implementation, QA, and delivery. So you might think how it is possible, but let me walk you through some of them. So some such methods are Agile Scrum. As I said, most companies follow that. Agile Scrum have daily stand-ups, which is what I described previously. So Agile Scrum has cycles, and different days in this cycle looks different. So in a later slide, I will show you on day 1 of a cycle, this is what we do. Day 2 of a cycle, this is what we do. Day 3 and likewise, right? So you will know what a cycle is and all that. So different days look different as we progress through a cycle. So let's first try to understand what Agile Scrum is. So it's a software development process which allows us to do continuous planning, development, and delivery. So how do we do this continuous planning, development, and delivery? Basically, we call it a PDCA cycle. We plan, we implement, we check with the customer, that is actually the delivery point, whether this is what he wants, and takes his feedback and act on it, right? So all of these things happen during a cycle, and there are several cycles of it. So initially you plan 3 cycles. When we get a project, we would say, looking at the project size and everything, we'll say we'll deliver it in 4 cycles. Each cycle will be 2 weeks. Something like that we establish. After that, within this each cycle, we do PDCA. So this cycle is called a sprint. This is how usually a Agile Scrum process works. So basically, let's say we get a project with 10 features. So this is a project with 10 features. Each of these box has a feature. Think of it as a feature. So we say in sprint 1, we'll deliver 3 features. In sprint 2, we'll deliver 4 features. In sprint 3, we deliver 3 features. And we break it down. And at each of these end of the sprint, we'll have shippable 3 features. It will have an acceptance criteria. We have to achieve the acceptance criteria within the 2 or 3 weeks. Sprint recommended sprint size is usually 2 to 4 weeks. Our sprints are 2 weeks. So we say at the end of this feature 1, we will have this, and those acceptance criteria must be achieved. So even features can span across cycles. Like say we have a big feature, we can do feature 1 part 1 here. Let's say feature 11. Feature 11 part 1 here, part 2 here, part 3. But before we start, we have to say this is what we are going to achieve. And at the point we are finishing, we have to achieve what we say. So it's a very self-managed system. So at the end of a sprint, we do a demo to the customer and ask whether it's what they want. If not, if it is what they want, that's great. We have delivered. If it is not what they want, we either take the feedback, plan it to a sprint 2 or sprint 3, likewise. So at this point, I would like to so this is another iterative development. So you asked to draw Mona Lisa, you develop it in sprint. This is more of a feature cross-cutting approach than feature-wise approach. So at this point, I would like to stop and ask you whether you have any questions, because to proceed, I want to make sure that you have understood. You can type in the questions if you want, or you can even ask. I'll give you maybe 30 seconds, 1 minute. Is there a chat? Yeah, yes, I have one question. I will answer this after towards the end. I'll take that question towards the end. Okay, looks like everybody's good on Agile Scrum, how we do iterative development. So let me move on. So I said we have sprint planning. So 2 to 4 week sprint. We identify a set of features from the available backlog, and we deliver a shippable or shippable set of features. So I have a question. So that the question is, Jira is part of Agile. So I think the question is whether Jira is part of Agile. I would say no. Jira is a bug tracking system. So it's a different thing. Even Jira was there when we were doing, when we were following waterfall also. So as I recall, yes, or Bugzilla was there. It's just a ticketing system. In GitHub, if you go, you can create a ticket and or a bug, and then you can track the progression of the bug. So Jira is software, Agile is a process. So Agile is a process, Jira is a software. To do Agile makes sure that you develop a product, develop a software, or give a software service or ISP service or whatever. Jira is just a software, Agile is a process. So waterfall is the process. So Agile. So here, as you can see, we have lot of, let's say we have lot of features to be developed. We call it the backlog. Let's say there are 100 features to be developed. And then before starting a sprint, we identify these 10 features are going into current sprint. These 10 features are going to next sprint. So this is called the grooming backlog. This is called the sprint backlog. Sprint backlog is the one we are writing code, doing QA and planning, and then actually showing to the customer. Grooming backlog is the one we are studying. Before we do anything, we have to understand what's required. We have to do class diagrams if required. We have to design where the attributes should go, whether there should be an API, whether there should be a button. If it is a UI, we have to design on the UX. Grooming is the activity where we elaborate requirements given to us by the business analyst. So business analyst just would say, I need to apply for leave. There should be a button that to apply for leave. When I click on that button, I should get a calendar and a small text box to add the reason and then select the manager and submit. So something like that. So you need to elaborate that, right? So grooming is the activity that you do wireframes, where you do your API designs, where you draw your class diagrams. So during a sprint, we just don't write code. Like if you think for 8 hours of the day, we do scrum and the rest of the time we write code. No, we write code and we read documents written by BA folks and do groundwork for it, do designs that will allow us to write code in the next sprint. So there are two things: grooming backlog, sprint backlog. So basically, we don't just, what I'm saying is not just writing code. You just have to be able to read something, understand it, elaborate it, ask questions, and based on that questions, think about it, and then elaborate it more. If it is not clear, you should say, okay, I can't do this. This is not clear enough. If it is clear, you go ahead and develop it, right? So this also brings us to something called full stack development, which I want to talk about, because more and more we are doing all of these activities in a sprint. We elaborate requirements. We right. Previously, architects did the design and just gave us. We just got the design document with everything. We wrote it down. But right now, there's only probably one architect who's specializing in that. He is overlooking grooming task of all the engineers. There are QA folks who are specializing in that task, that are doing automation, probably not doing manual QA, and who are involved from the day one of the planning, grooming activities and doing that. Today, more and more, the industry is looking for full stack developers because they want people who can do front end, back end, database developers, and develop tested code, as in at least second level of testing should be done. Happy paths should work, very well known edge cases should work, unhappy paths, at least couple of unhappy paths should, giving it the QA, and the QA person will sit with you and do the testing. So if you are like if you look at the process, you can see from it falls in line with the expectation that we are looking for well-rounded engineers, they're self-disciplined, motivated folks who are responsible, who are passionate about what they do, right? So you should, so you can see, and it is aligned with modern architectural concepts as microservices, because microservices has this concept of SRP, single responsibility point, where couple or 3 or 4 folks own a feature from inception to deployment. They should be able to elaborate requirements and then develop it. That team will also have a QA engineer, test it and take all the way to deployment. So they have to attend all the support, maintenance work, everything. So to do this, you should have a skill set that is not just writing code. It requires much more than just writing code. Of course, writing code is the bigger part. In addition to that, you have to do a whole lot of other things. So this is how usually our sprint looks like. On the day one of the sprint, we do sprint planning. This takes about 2 hours because we say I don't want to go into details of Agile, where we do story points and all that, but just want to highlight that as a team we plan. It's not just project manager saying task 1, task 2, task 2, task 3 goes like this. As a team we plan. So as a software engineer, you should give your input and participate that sprint planning activity, and then actually we start work, right? So by day 2, we expect at least 10% of the day work is done. Day 3, at least 20% of the backlog, like the backlog is done. And you, depending on the week, depending on the plan, we might use either on a Thursday or a Wednesday. We may push the previous sprint work to production. So if it was approved by the product owner, in our case, it is the product owner, we don't have a customer. Product owner is the one who says the product should be like this and like this. You can also, he's the one who does market analysis and says, okay, this product should have this feature in this manner. So he works closely with the BA business analyst and give us requirements. And during the sprint demo, day 10, we do the sprint demo and retro. During that time, if the customer is happy, we plan the deployment activity on the previous week. Day 3 or day 4, we push it out to production. So that is usually done by developer together with one SRE. So 3 developers, 3 things to push to production, SRE cannot do all of them. Basically, it's going to be a joint activity. So you should be Linux commands, deployment practices. You should be curious enough, maybe development practices. So Kubernetes, if the deployment is done on Kubernetes, Kubernetes will be useful if the deployment is done on AWS. You should learn a bit about it. I'm not saying you have to be an expert at it, but you have to know enough to manage along with the SRE. SRE will be there to help you, guide you, and then hold your hand. But you should not be a complete newbie. You should not be like a fish out of the water in the Linux environment. You should know how to navigate stuff, be supportive, and because we do all the activities as a team. So it's not just writing code, you also should know a little bit about deployment. You don't have to be an expert, but know a little bit. And then on Friday, we usually start reviewing all the documents for the activities for the upcoming sprint. We do the design review. So at for the next sprint, so this is the day I have most work, because I have to do I have to do like deployment cutover, document review, all of that in a day. So if there are 2 teams, if I am the architect for 2 teams, I make sure that they don't have day 5 on the same day. Team A is also having design reviews on the same day. Team B is also having design reviews on the same day. So basically, we have interchanging design reviews. So after the design review, start grooming their stories. So grooming their stories means they detail it down, break it down, ask questions, and plan. This is how we are going to do it. If it is algorithm, write a sequence diagram, write pseudocode, basically get ready for the next sprint, right? On day 7, we have mid-sprint review, and then the grooming and work continues. And on the final day, we have the demo and the retro. this is a typo. This should be 90% about that. We have the final bugs fixing, then retro and the demo to the product owner. So it's not the same person who's doing the demo. Different people will be doing the demo on different days. You should be having presentation skills, right? So this is how a day, different days are different. Any questions? Can probably spend 30 seconds on these related topics. Okay, so let's move on. Okay, so that brings us to the skill set. Before going to the skill set, this is just Agile manifesto. I mean, we don't have to stick to it, but more and more today, companies are relying over individual interactions over documents. Like 15 years ago, we didn't even I mean, we didn't have the bigger picture. We only got a document saying you have to write this code, this is the method signature, this is what should be the outcome, and we did it. But today, we don't get that document, right? So today you won't get it. You won't get that document. You have to interact with the team, interact with the product owner, ask the BA. You have to be responsible for those writing your code. You have to be responsible for the functionality of the code. So basically there's over documentation, there's a lot of negotiations, customer collaborations, teamwork. This requires a lot of soft skills from a developer. So I just wanted to highlight first the I think I'm missing a slide here. Okay, anyway. So basically this requires a lot of soft skills. So we have a lot of closely knitted teams. So you have to know, you have to have best team skills, teamwork. You cannot work as an individual. If you want to work as an individual, most probably you might have to work as a freelancer or something like that. But if you are working in the industry, in a mid to large size company, even in startups, we need to, you have to have excellent interpersonal interactions. So this is called emotional intelligence. You have to know you. This means you have to know you, and you have to understand other person's emotions, and you have to act according to the situation, right? So this is something you can learn as it's difficult to learn than maths, but it is learnable. So communication is utmost important in this kind of an environment, because you're supposed to you have to know when to escalate, when to speak, when to say I can't do this, when to say when to ask questions, which questions to ask, from whom to ask. There's a lot of complexity you will have to navigate, but it's all fun. And attitude is very important. You should be able to work with the team. You should be open for feedback. You should be adaptive. Like you should be able to learn, relearn, unlearn, all of those things. So when we hire, these are the top skills we look at: the teamwork, your attitude, communication, and these are exactly that. So, but if you are to actually be successful, you need to have a lot of you have to deliver what you say. Otherwise, the team will notice that you are slowing them down, because there are like velocity, you have to achieve these things. So basically, same. You really have to be passionate about what you do. You have to be responsible, hardworking, and all that. And the next thing, tech skills. So number one thing that you need is analytical skills, right? Because without analytical skills, you won't be able to write an algorithm, find a solution to a problem, identify the problem. So basically you need a top meter, right? Have to have analytical skills. So there may be other engineering disciplines where some concepts are not used. Like you learn it, you answer the exam paper, and you never have to worry about it again. As long as you pass the exam, you can completely forget all the subject matter and still go and have a great career. But one thing I can tell you is, if you have it's essential that you have your foundations really strong. You should know operating systems, database, programming language, class, APIs, web distributed systems. You have to have all these foundations strong. That is the only thing that will keep you going for 10 plus years. Otherwise, in 10 plus years, you'll be outdated. Because why? Because languages change, right? Operating systems get upgraded. And then web services, REST overcomes web. So all of these things happen, right? New concepts come in. But all of these new things go back to foundations. If you can link them to what you learn in the class, it will be easier for you to understand all of these new things that are coming up, right? Words may scare you, but if you actually go and read the description of that, you can easily understand, okay, it's just like for example, Kubernetes, people get fried. But if you go and read it, you can say, okay, it's like virtual machines, but it has some more advantages than a virtual machine, right? It's like a jailed Linux jails, Unix jails. So these kind of things, it's really if you have learned it, and if you can map these concepts, it's really easy for you to get familiar with new technologies. So coming from a person who has been in the industry since 2004, that's the most valuable thing that has kept me going. Okay, next comes your development skills. Whatever the language, Java, Python, VB, whatever that drives you, whatever that motivates you, you should be an expert on at least one language, one modern language. So it will help you to get a job immediately when you pass out from the university. Even a person without a degree who knows Java well, who knows his language well, and who has top analytical skills can get a job. In the industry, it's not a requirement that you need to have a degree. I have worked with superb software engineers who have not completed their degrees. They don't have the degree to their name, but they have top analytical skills. They have top development skills. They might lack foundation, but their curiosity make up for it. Because if they find something, they read on it, they go research on it, they do a hands-on tutorial on it, they read a book on it. So there are developers who don't have the degree, but excellent developers, top analytical skills, and curation leads them to eventually gain the foundational knowledge that given in a degree, right? So they are the best developers that I have seen, like in the industry, like cool. I mean, put in like a lot of hard work. I don't think they consider it as hard work because they are truly passionate about what they do. That has driven them to learn their development skills, probably mostly alone, but probably get a certificate if at all required. But most of the time they make the cut, they make the interview, they pass the coding exam, and they make it become a software developer. And you also need to have common sense, because common sense leads you to understand how to write your code, not just to cover the happy part. You have to cover at least several unhappy parts, because as of today, it's not acceptable to write a code that works only in the happy part. And as I said, you also need to know your step up your deployment skills, because that will be required, right? It's okay not to know these things on the first day, but if you, when you join a project, if you think that if you find, when you join a project and you find out that they are on Google Cloud, get a free account, because Google gives you free credits, and learn about Google Cloud. Create an instance, create a load balancer, create a auto scaling group, learn about it. So it's all free. AWS gives you free account. If you find out that you are on AWS, do that. So be curious, keep learning, and I think that will take you a long way. Okay, so any questions? I think I will take most questions now, because the last section I can cover. So I will take questions previously asked. Let me see. Okay, so there's a question from there's a question. I am passionate about web development, therefore I'm fully focusing on web development technologies. Do you think it's good to focus on web development rather than focusing on other technologies? Yes, if you're passionate about web development, certainly you should concentrate on that, because web developers are like, that's a high demand for web developers. And also get your foundational skills such as operating systems, database concepts. So you'll be good. And HTTP. So if you are into web development, you should know basics of HTTP, different web servers. Those things you can always learn, but cover the whole ground, but go deep into one specific thing. So if you are passionate about web development, go deep into that, but also know
Dimatu, we can't hear you. Yes. Dimatu?
Hello?
We lost you, Dimatu. We lost the screen sharing as well.
Okay, what was the last thing you heard? I'm sorry, I didn't know.
Man in the support desk.
Okay. Did you hear one I said about, I answered the web development question.
This is the one.
This is where you stop. Yeah.
Yeah.
Okay. Okay, so I will go to manning the support desk section, because that is another aspect of a software developer. So, so you now develop your system and put into production. So what is support? Making sure that the product, your software run according to the client's needs. Basically, if your software is authenticated software, it should authenticate all the users. If it is a hotel reservation system, it should run perfectly. When you hit the reserve hotel button, it should reserve your room. Likewise. So there are different levels of problems. Some problems are more severe than others. So highest level of problems occur when business cannot continue, when the system is down. Right? When the system is down, when the business cannot continue, that's a huge problem. You have to attend to it immediately. Another point is if your system slows down and the clients are impacted, that's another problem, right? So you need to fix this, but it might not be as critical as the previous problem. Another problem is you might identify problems that can become blockers in the future. You can see our system is running out of memory very frequently. Alarms are telling that probably the database is running out of this space, and according to your analysis, you can see it might run out of space in 2 weeks. So it might become a problem. If you don't attend to it, it might become a problem. So all of these are maintenance issues that you have to attend to. In addition, users might have issues. These are low impact issues. Users might say, I cannot log in, I cannot book, I enter my credit card details, which are still valid, but if he's saying the credit card is expired, your system is having a wrong validation. Likewise, I made a reservation, but I didn't get the confirmation email. So many questions. Those are low impact queries, live chat, all of these things. Usually to handle all of these different types of problems, we have a support team. To support the support team, almost the engineers are put on 24-hour on-call duty, right? So these are called L1, L2, L3 issues. Engineers are put on 24-hour on-call duty, just like doctors. But luckily, unlike doctors, we don't get so many calls. For the whole last year, I have just got 2 calls, 2 incidents. So one is L2 and another one is L3 because we write superb software. So that's another motivation for engineers to write good quality software, because to make sure that you won't get called in the night. Some companies have special engineers to attend, support engineers to attend these main problems, but still put you on call for 24 hours on a rotation basis. I mean, that doesn't mean you have to wake up 24 hours. It just means you have to keep the phone near you all the time. So you have, if you are on the rotation, if an incident happens, you might have to help the support engineers to resolve the problem. So that's another expectation from you as a software engineer. So this is usually how support, if in some companies you are expected to play the support engineer role at least a few weeks per year. Some companies don't expect you to play the support role, but rather expect you to help the support engineers by being on call 24/7. So this is how support engineers work. Remember, I showed you modern software development process. Kanban is another process, mainly used by the support desk engineers. So Kanban has swim lanes like race tickets, attending tickets, and done tickets. So here So Kanban is originally is a Japanese word. Kanban methodology came from Japan, manufacturing industry. Now, most of the software development companies also using Kanban as a process. So Kanban is a very popular process that is used by some companies. And Kanban is the #1 choice for support desk activities. Okay, so these are some of the Kanban practices. It says you have to continuously improve the process using the feedback of the team, the customers. Feedback loops must be healthy. You should, if somebody says some idea, no idea is a stupid idea, you have to always evaluate that idea, and if you can improve the process, please do so, and visualize the workflow in swim lanes. And then you have to keep not have many doing things. You have to push them out to the done things before picking up items from the to-do list. So these are few of the Kanban practices. It's really simple but very powerful. Okay, so this is a Kanban chart of a operations team or a support team. New task, accepted task, active task, closed, rejected tasks. Okay, so this is the final slide that I have for you. So if you want to have a long tech life as a techie, always have a foundation, keep learning, keep reading, keep listening to webinars. Webinars are a great way to get yourself updated. Do small tutorials, experiment, and build something fun. If you want, do tech certification as a target. I mean, I personally don't do tech certifications. I just follow the course because it helps me to see the different aspects of new technologies. And of course, follow online courses. There are so many today and so cheap. As low as $9 you can get fantastic courses. So